Okay, so in this example, we're going to be dealing with vector applications, and in particular, we're going to be dealing with bearing problems. And we want to find the resultant velocity and direction. So we're going to go ahead and talk about bearing and what that means and how to put that on. But why don't we go ahead and read our first example here, and then we'll talk about what we need to do to set up the problem. Okay, so I'm going to go ahead and scroll down here. That way I have room, because I'm going to need some room here to do these problems. Okay. It says an airplane is heading northwest at 30 degrees. So again, this means northwest. When you see N and then you see 30 degrees and then the W, that means northwest, right? 30 degrees. At a speed of 300 miles per hour. A wind blows from the east at 40 miles per hour. Find the plane's resultant velocity and direction. So they want two things here. They want the resultant velocity and they want the resultant direction, okay? So the first thing that we have to understand is, what is bearing? Now, bearing is really easy. And all you really have to do is draw a coordinate grid. So I'm going to go ahead and do that right now. Just putting on a coordinate grid. And bearing will always be in respect to the y-axis. So for example, if you look at my first bearing, it says north 30 degrees west. So we know that this is going to be north. This is going to be east, right? This will be south, and this will be west, okay? So if I'm going northwest, that's going to be in this direction here. And so I'm going to go ahead and put on my vector here. And so my bearing will be in respect to the y-axis right here, meaning this is going to be 30 degrees, okay? So that's pretty much how you would put on bearing. It's pretty easy. All you have to remember is it's always going to be in respect to the y-axis, okay? So this is actually how the first part of this problem is going to look, okay? But I'm going to go ahead and give myself some more room here, and we're going to do these one at a time. All right, so for example, our first step is to draw a coordinate grid, and that's what we're going to do. So getting rid of this here, we're going to put on our coordinate grid. I'll put it on right here, and we'll go from there. So we already talked about how our first vector is going to be going northwest, and it's going to be 30 degrees. So I'm going to go ahead and put on that vector. So there it is right here. And from here, I'm just going to go ahead and put on that angle, which is 30 degrees. And again, that's in respect to the y. So right here, this will be 30 degrees. Okay, good. From here, we have to put on our next vector. Now, what happens? It says a wind blows from the east at 40 miles per hour. So from here, you want to put on another coordinate grid. Now think about it. The tip of this vector right here, what quadrant is it going to fall in if you draw another coordinate grid? Well, that's going to fall in the fourth quadrant. So for example, when you put on your new coordinate grid, it's going to look the following way, where the tip of that last vector is right in the fourth quadrant, like that, okay? And we can extend this a little bit more. There we go. And so now we're going to do the same thing. We're going to put on another vector. Now this one is going to be coming from the east because the wind is blowing from the east. So it's actually going to be heading towards the west, if that makes sense. So for example, this vector that we're going to be putting on is coming from the east like this, right? Heading towards the west. That would be a wind blowing from the east, right? So there we go. And now from here, all you have to do is connect your vectors to make your resultant vector. So I go from the tail of my first vector and I connect it to the tip of my last vector. And I'm actually going to do this one in a different color. That way we can differentiate between the resultant vector. So for example, drawing on my last vector, my resultant vector, it's going to look like this here. Okay? Now from here, we can start filling in information. I know that my first vector is going to be represented by 300 miles per hour. So I'm going to put here 300 miles per hour. Okay? We know that this vector right here is the wind. That's going to be 40 miles per hour. Okay. What else do we know? Well, we know that we're trying to find this red vector here, right? That resultant vector. How are we going to do that? Well, if you look at it, I have side. Then I have this angle in here that I don't know yet. And I also have side here. Well, if we have side, angle, side, we can solve that using the law of cosines, right? So can I get that angle inside? And the answer is I can, right? So for example, I know that this right here is going to be 90 degrees. And I also know this angle right here. And I know that angle because of alternate interior angles. If this is 30 degrees right here, that means that this angle right here must also be 30 degrees, okay? Because we have a vector passing through two parallel lines, those two parallel lines being the x-axis on my coordinate grids, okay? And so as a result, that's going to form alternate interior angles, meaning this angle right here is going to be 30 degrees. So all I have to do here is 30 plus 90. And when I do that, I get 120. So this whole angle right here is 120 degrees. So from here, we can now get the resultant velocity, and then we'll work on the resultant direction at the end, okay? So how are we going to do that? Well, we're going to use the law of cosines. Now, I didn't label this triangle, but I'll go ahead and do that right now. I'll just call this angle A, I'll call this angle B, and I'll call this angle C right here, okay? You can call it whatever you want. And so essentially what I want to do is I want to solve for side B, okay? So in order to do that, we're going to use the law of cosines. Now, again, you should be proficient in the law of cosines. So if you need to go back and look at those formulas, go ahead and do that. But I'm just going to go for it right now. So the law of cosines is going to look the following way. Since I'm trying to solve for side B, I'm going to have B squared equal to A squared plus C squared, then minus 2 times A times C, and then cosine of angle B. So cosine of angle B, from here, I just have to plug it in and solve, okay? So I'll get B squared equal to, well, A squared is going to be 40, okay? And again, I know that because it's opposite from angle A, right? So this right here, this side length right here is going to be side A because it's opposite to angle A. Same thing. This side length right here, this resultant vector, is going to be side B because it's opposite from angle B. And again, you should know that, right? So again, we have 40 squared and then plus, well, side C here is going to be 300, so 300 squared minus 2 times A times C. So again, 40 times 300, and then cosine of angle B, so cosine of 120 degrees. Okay, there it is. From here, you just have to plug it into your calculator, and you should be able to do this all in one go. Just make sure you are, in fact, in degrees. So I'm just going to write here B squared is equal to, and now I'm going to plug this into my calculator. So I get here 40 squared plus 300 squared minus 2 times 40 times 300, and then finally times cosine of 120 degrees. Again, make sure you are in degrees when doing this. When you calculate this out, you should get the following: 103,600. So 103,600. Now from here, I just have to take the square root on both sides, and then I will get that resultant velocity. So taking the square root on both sides, I get the following. I get 321, and I'm going to round to the nearest hundredth here. So we get 321.87. So 0.87, and that's going to be in miles per hour, okay? That right there is going to be the resultant velocity, or in other words, side B, okay? There it is. All right, so that's part one. Now, part two, we have to find that resultant direction. So you have to look at your resultant vector, and again, we're talking about bearing here, so it's always in respect to the y-axis. So they actually want this angle right here, okay? So how do I do that? Well, I have the 30 degrees, but I don't have this inner angle right here. So how do I get that inner angle? Well, I can use the law of sines, right? And I can use the law of sines because now I have a ratio. I can use this 321.87 as part of my ratio. So for example, up here, I'm going to write sine of 120 degrees all over the opposite side, which is 321.87. Okay, there's my sine ratio. Set that equal to what we're trying to solve for. So again, I'm trying to solve for angle A here, that inner angle, right? So I'm going to say sine A over the opposite side, which is going to be 40. From here, we just have to solve for angle A, and we'll have it. So in your calculator, you're going to do sine of 120 degrees, and then we're going to divide by 321.87, okay? Multiply by 40, so times 40. And so now you have sine A equal to your value, which is an irrational number. I'm just going to call it A and S. So A and S. And so to solve for this, all you have to do is inverse sine. So angle A is going to be equal to inverse sine of my answer. So I'm going to do inverse sine, and then I want to look for that A and S button. You should have that on your calculator. That grabs the previous answer, right? And so when you take inverse sine of that, you get angle A is equal to 6.18. So 6.18 degrees. Now again, that is angle A. We want this entire angle here. So I have to take 30 degrees and add it to that angle A that we just found. And so I'm going to say here north, and then 36.18 degrees, and then west, right? That is my direction. Okay, so there we go. All right. Why don't we go ahead and try another example? Okay, so here's our next example. In this one, we're dealing with a boat. It says the following: a boat travels southwest at 40 degrees for 340 miles. Now, I'm actually going to stop right here. I can go ahead and put on my vector based on that information. So that's going to result in one coordinate grid right there. So I'm going to go ahead and put on my coordinate grid, making sure I'm leaving myself room. All right, so going ahead and putting on my coordinate grid. And this is going in the southwest direction. So again, that's going to be in this direction here. Okay, so there we go. And this is going to have a bearing of 40 degrees. So again, that's always in respect to the y. So right here, I'm going to put 40 degrees. Okay. It then goes on to say it then pivots and begins to travel southwest at 10 degrees for 200 miles. So there's another vector I can put on. So the tip of my last vector is going to end up in the first quadrant. So for example, putting on my new coordinate grid, I'm going to have something that looks like this. Okay. And the new direction, again, is going southwest at 10 degrees. So that's going to be in this direction here. Okay. And we know that our bearing there is going to be 10 degrees. So the angular value right here is 10. Okay. We now have enough information to go ahead and put on a resultant vector. So starting at our first vector, we're going to start at the end and go to the tip of our new vector. Okay, right here. There we go. Okay, so now we have our triangle. So we can start filling in our information now, and then we can go from there. So we know that this right here is going to be 340. So I'm going to put 340. And again, that is miles, but I'm going to leave off the units for now. That way we have room. And then the next side here is going to be 200. That's going to be 200 miles. Okay, again, leaving off the units for now. And so I almost have side angle side, and then I'll be able to solve for this resultant vector in red. But I need to get this entire angle right here, right? So how do I do that? Well, remember alternate interior angles. We know that this entire angle right here is 40 degrees. That means that this angle right here also has to be 40 degrees. And if that's 40 degrees, that means that this angle right here is going to be 50 degrees because it has to add up to 90, right? So I know that this right here is 50, this right here is going to be 90, and then I have the 10. So I'm doing 10 plus 90 plus 50, and that's going to give me 150, okay? So this entire angle inside here is going to be 150 degrees. So again, this whole thing here is 150 degrees, all right? And so from here, I have side angle side. So again, I have side angle side. I can use the law of cosines. Go ahead and label your triangle. This will be angle A, this will be angle B, and this will be angle C. Again, it doesn't matter how you call it. And so essentially, I'm trying to solve for side B, okay? So again, writing out the law of cosines, that is going to be B squared equal to A squared plus C squared minus 2 times A times C, and then cosine of angle B. So cosine of angle B, all right? Then I'm going to have B squared equal to, so what is A? Well, for me, that is going to be 200. So 200 squared plus what's C? Well, that's going to be 340. So 340 squared minus 2, and then we have times 200 times 340, and then cosine of angle B, which is 150. Okay, there we go. So we just have to go ahead and plug this all into our calculator, and then we should be able to get it. So again, we're going to do this all in one go. We're going to do 200 squared plus 340 squared minus 2 times 200 times 340, and then times cosine of 150 degrees. Make sure you are in degrees, okay? When you do that, you should get a fairly large number, and that is going to be 273, and then we have 379. Rounding to the nearest hundredth, we'll get 0.45, okay? All we have to do is take the square root of this number now. So taking the square root of this number, we get the following. We get 522.86. So 522.86, and again, that is going to be miles, is going to be the resultant magnitude of that vector, okay, or the resultant distance, okay? So that is the boat's distance from the original starting point, 522.86 miles, okay? Now we're not done yet. We have to get the final bearing of this boat. So going from the original starting point to where it is now. So essentially what it wants is this angular value right here, okay? So we know that that whole angle there is 40, okay? So if I can get this inner angle right here, and then do 40 minus this inner angle, that's going to give me this angle that I need. Because again, that's going to be in respect to the y-axis. So again, this angle right here is what I'm looking for, okay? So if I do 40 minus this inner angle, that will give it to me. All right, so we're going to do the law of sines here. And I have a sine ratio, right? So I can do sine of 150 degrees all over the opposite side length, which is going to be 522.86, equal to what we're trying to find. So again, I'm trying to find angle A, so I'm going to say sine of angle A. The opposite side there is going to be 200. Okay? So we're going to go ahead and plug this into our calculator, and then we will get angle A. So I have to do sine of 150 degrees divided by 522.86. Then I have to multiply by 200. I get an irrational number there. So I'm just going to put sine of angle A is equal to my answer, again, which is an irrational number. And all I have to do here is do inverse sine. So angle A is going to be equal to inverse sine of that irrational number. I'm just going to call it A and S because that's how you're going to put it in your calculator. So I'm going to do inverse sine of A and S gives me 11.03, okay? And so again, angle A is going to be equal to 11.03. Now, you're not done yet, okay? Remember, I now have to take 40 and subtract this number from it. So I have to do 40 degrees minus 11.03, and that's going to give me the resultant bearing, right? So I'm going to do 40 minus 11.03, and that will give me 28.97. That's the angle I'm looking for. And again, it's this angle right here that we just found. Again, 28.97, and that's going in the southwest direction. So I'm going to say here south, 28.97 degrees, and again, west. Okay, so the southwest direction, and I do have the angular value in between, right? And so there it is. There is my resultant direction, okay? And so that is it. Those are vector application problems, and in particular, when you're dealing with bearing. So I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.